Hello, everyone, and welcome to the second pre-recorded video of 20th November 2020. Uh, and we are discussing the chapter geothermics. And today we are going to discuss around geothermal energy. So, sources of the Earth's internal energy. We discussed a little bit about this in the earlier video, but we will see what it is. So, 70% of it comes from the decay of radioactive nuclei with long half lives that are embedded within the Earth. Okay? So, major source of the heat is by the radioactive decay. Some energy is from the residual heat over the Earth's formation. As you know, Earth had a very high temperature when it formed, and then it is slowly decreasing its temperature because it wants to come back to equilibrium. Why it wants to come back to equilibrium and how it comes back to equilibrium, we discussed them in the last video. I hope you remember them. And the rest of the energy comes from meteoritic impact. So we want to use that particular heat energy of the earth for our own purposes. So that brings us to the discussion of different geothermal energy sources. So first ones are the hot water reservoirs. As the name implies, these are the reservoirs of hot underground water. There is large amount of them in the US, but they are more suited for space heating and than for electricity production. So the idea is we are trying to cultivate these geothermal sources and try to form electricity from them. How we will discuss later. So the first category is hot water reservoir. There are some reservoirs which has of hot underground water, not very deep, but they don't have enough potential to form electricity. They're mostly used to actually heat up the houses. Now, natural steam reservoir, another type of reservoir. In this case, a hole is dug into the ground that can cause steam to come to the surface. This type of resources is rare in the US. Okay. Uh, So the geothermal is mostly developed in the US. So most of the references are coming from US as well. Okay, so it's not very much there in India. I think one or two demonstration project that has happened, and that's about it. So most of the references you will find from US and the Europe. Okay, so natural steam reservoir. Sorry, this is not steam. This will be steam. Okay, this is natural steam. So what it essentially means that you will from those there are some hot reservoirs from where steam actually comes out, which are immediately below the ground. So you can dig a small hole and actually use that steam for your work. Now geopressure reservoir are generally the high pressure reservoir or the overpressure reservoir. We talked about overpressure reservoir uh, in during the stress discussion. So these are the same overpressure reservoir. In this type of reserve, brine, which is like salt saturated water, can be completely saturated with natural gas stored under pressure from the weight of the overlying rock. This type of resources can be used for both heat and for natural gas. Now, normal geothermal gradient, as we say, at any place of the planet, there is a normal geothermal gradient is around 30 degrees centigrade per kilometer. Therefore, if one digs 20,000 feet, the temperature will be 190 degrees centigrade above the surface temperature. This difference will be enough to produce electricity. So you have to dig with the normal geothermal gradient, you have to dig around 20,000 foot. And that temperature difference between the surface and the underneath will be enough to actually create electricity. But then, of course, if I have a but that will be no useful and will be uneconomic as well. Okay, so that will not be a very viable idea. So you have to, if you want to harvest on geothermal energy, you have to actually harvest in an area where the geothermal gradients are steeper. Okay, but the crust is perhaps a little bit shallow, and or I have a nearby heat source which is emitting a lot of radiation. Say, for example, I have a granitic pluton immediately beneath the top part of the crust, and that can actually supply additional heat energy, and the geothermal gradient can be steeper, and that geothermal gradient can be such steep geothermal gradient can be used for geothermal energy. Now, hot dry rock, this type of condition exists 5% in the US. It is similar to the normal geothermal gradient, but the gradient is around 40 degrees centigrade per kilometer. Molten magma, no technology exists to tap the heat reserves in the magma. The best sources for this in the US are in Alaska and in Hawaii. So, how geothermal heat energy is used? So, direct use of geothermal energy is appropriate for sources below 150 degrees centigrade. It can be used for space heating, air conditioning, industrial purposes, drying, greenhouses. Even see this is greenhouse, which is heated by a geothermal energy. Aquaculture, you can see there are these are this is a fish farm where the temperature is elevated so that these fishes can survive. Maybe some exotic fishes can survive because the outside temperature can be very cold, and you keep the water warmer for these fishes to survive, and that you do essentially by the um, geothermal energy. You can use them in resorts and pools where people do enjoy taking a bath in a hot pool, and of course you can use it for melting snow. So, how direct uses work? Direct sources function by sending water down a well to be heated by the earth's warmth. So, this is very simple that you actually drill a shallow well and through which you pump some water. When that water goes down, it gets heated up by the internal energy of the earth. I mean, because the earth inside is hotter. So, and then with another well, you take the water out. The water that you have pumped in, you take the water out. And while it is going through that beautiful artesian well and being in touch with the hotter inside of the earth, the water that comes out is hotter, right? It's hotter than the water that you have sent. So what you are gaining, essentially you are gaining the heat energy, and that heat energy can be used for many different purposes. Either you can directly use that hot water for any of your purposes that I have just described, or you can extract the heat from that hot water and run a turbine and create electricity. So then a heat pump is used to take the heat from the underground water substance that heats the house. Then after the water is cooled and injected back into the earth. Okay. So this is a beautiful borehole heat exchanger, ground heat collectors. This system uses horizon. So this is like the floor heating of a house. Remember, if you are living in Europe or in the US, and if your house has floor heating, that means the generally you have wall heating, that there is like some heaters and that it heats your house. It's really nice. But then if you have floor heating, that means you are really, really rich. To install this system, it takes a lot of money. That means hot water actually runs beneath the house, beneath the floor. Okay, and that keeps the temperature a little bit elevated. And when the outside is like minus 15, minus 20 degrees centigrade, you like to walk on a floor which is slightly warm. It's a luxury. Okay, so the idea is that there is a well, there is a pipeline. That well actually goes in the subsurface for some depth, and through a pump you essentially put cold water through it. It goes down, and it gets heated up because of the temperature difference of the surface and beneath, and the hot water comes up, and that hot water is actually circled through your floor, and then when it loses the heat in this process, and the cold water is again pumped back and the hot water comes up. Okay, so this is what we call as bore heat exchange, and this is used typically for space heating, as I said. Okay. Now, the generation of electricity only happens at this temperature, which comes up as a temperature of more than 150 degrees centigrade. Okay, so what you can do in this particular thing, there are different types of things that can happen. So the first one is dry steam plant. These were the first type of plants that were created. They use the underground steam directly to the turbine. Okay, so here instead of water, the underground water is so hot that the steam comes out. You can see dry natural streams of water vapor coming out from underground. You can actually take them out in a controlled way, and that steam can actually rotate your turbine and you can create electricity. The water which is created after this process is actually pumped back into the ground. So these are called dry steam plants. Dry steam plants. Now, flash steam plants, what happens in flash steam plants? In this particular cases, the temperature, it's not steam that comes up. What comes up is essentially your hot water. Then that hot water actually is streamed through some nozzles in high pressure, and that, because of the pressure release, it creates water vapor. That water vapor runs the turbine, and the cold water that is formed as a product of this exchange is pumped back inside the ground. Now then, binary cycle plants. What happens in binary cycle plants? There is an heat exchanger. So here I have water, okay, which is perhaps cannot generate steam by the process that I have mentioned in the previous slide. So what you essentially put a fluid here which has a lower boiling point. Okay, which is a lower boiling point. So this is the water pipeline, and this is the pipeline for a fluid which has lower boiling point, and there is a heat exchange happening. And that heat exchange, what it does, it can actually create steam in the lower boiling point fluid. So you are not directly using the water, but you are taking the heat of the water into your low boiling point fluid material that is creating the steam and rotating the turbine. Okay. Now, hot dry rocks. What happens in hot dry rocks? So, say for example, here I have a source which is, say for example, I have a fractured granite, and granite has a lot of radioactive material. So it is a heat source because it continuously emits, uh, does radioactive decay. So what you do, you essentially pump cold water inside into the fractured system of that hot dry rock, you know and the water actually percolates through the porosity and permeability of the hot dry rock, be there for some time, gets heated up, and with other wells you actually take up the hot water, and then that hot water can be used in a heat exchange and be used for electricity generation or heating your private spaces. So what are the harmful effects of geothermal energy? It's actually very clean form of energy. There is no carbon dioxide emission. Okay, so it's absolutely no combustion that is required. So the carbon footprint is absolutely very small. So which is a very good news. Okay, now what are the harmful effects? What are the limitations? Brine can salinate the soil if the water is not injected back in the reservoir after the heat is extracted. Extracting large amount of water can cause land subsidence because you are doing some sort of pressure imbalance as well that happens in oil and gas exploitation as well. And this can lead to the increase in seismic activity, although small scale, to prevent prevent this. Cooled water must be injected back in the reservoir to keep the water pressure constant underground. Okay, power plants that do not inject cooled water back into the ground can release H2S, because often these hot springs have H2S dissolved into them. Okay, or the rotten egg gas. H2S has a very bad smell, hence it is called rotten egg gas. This gas can cause problem if large quantities escape because of inhaling can be fatal. Okay. One well blew its top 10 years after it was built, and this threw thousands tons of rocks, muds, steams into the atmosphere. But such incidents only happen once in a blue moon. There is a fear of noise pollution while drilling the wells. Well, that happens everywhere. Now, what are the positive attributes? Useful minerals such as zinc, silica can be extracted from the underground water as a byproduct. Geothermal energy is homegrown. This would create job, better global trading position, less reliance on oil producing countries. US geothermal companies have signed 6 billion worth of contracts to build plants in foreign countries in the past couple of years. In large plants, it costs 4 to 8 cents per kilo out watt of water. The cost is almost competitive with conventional energy resources. The most important thing is, of course, it is clean source of energy. It doesn't really emit a lot of carbon dioxide into the atmosphere. Hence, it is extremely promising. Okay? So you can see where geothermal energy actually sits. This is gas, coal, wood, natural gas turbine, natural gas steam turbine, natural gas. So these are different ways how electricities are actually formed. Electricities are generated, and you can see the amount of pounds of CO2 per kilowatt hour, how minimalistic it is from geothermal sources. Okay. It's also the different type of other stuff which is thrown in the atmosphere. It's also very little polluting. So that the red bar indicates from oil field, the central heating, and the electricity powered by heat pump. Okay? So it's really, really the moral of the story. It's absolutely environment friendly. So these are the places where geothermal has geothermal potential. Of course, you see in India, it's just in the some places in the northeast, and this is mostly because people have not explored it properly as yet. You can see Europe is really ahead. Uh, yeah, in Australia as well, there are some places where geothermal is taken very seriously. Okay, so this is. The amount of this is the different countries which are involved in geothermal resources, and you can see the amount of electricities that they essentially generate for geothermal resources. So, moral of the story: geothermal resources is something which is coming up. It will not essentially be a really huge source of energy, but then of course it is extremely clean, and yeah, will be beneficial in future. Okay, thank you very much. So I will answer any questions that you might have on the next class, which will be on Wednesday. Thank you very much.